Assalamu alaikum, dear students. Welcome to Habib Niazi Physics. Today's topic of discussion is galvanometer, ammeter, and voltmeter. So be ready, take out your books and copies. Let's start with our lecture. So mark your attendance in live chat. Today's topic of discussion is what is galvanometer, what is ammeter, and we will discuss about voltmeter. Thank you very much for liking the lecture. All of you are requested to mark your attendance in live chat comment box. We were discussing about electricity, current electricity. Hi students, we were discussing about current electricity and we have studied about the definition of current, formula of current, its unit, conventional current. Now, the important topic is there. Today we will discuss about different instruments which are very compulsory in chapter of current electricity. So take out your copies and pencils and take out your textbook as well. We were discussing about current electricity. Like the lecture and we will start our lecture. All the students are requested to mark their attendance as well. So here is the time to start with our lecture. What is galvanometer? I have explained it and it's working in my previous lecture. So all of you are requested to give me answer in your comment box. What is galvanometer? I'm waiting for your response, for your answer. What is galvanometer? Waiting for your answer. Yes. Walaikum salam, not fake. Ibrahim Akram is saying an instrument for detecting and measuring small electric current. Ibrahim, galvanometer is not used to measure current. Galvanometer is just used to detect current. Is it clear? Galvanometer is a device which is used to detect current. It cannot measure current. I have explained the reason why can't this instrument measure the current. Because galvanometer is very sensitive instrument. Even a small amount of current can cause its needle to deflect through the full scale. This due to high sensitivity of this instrument, it cannot be used to measure current. This is just used to detect current. If you want to measure current, you will have to make some changes in galvanometer and you will have to convert it into ammeter. So the today topic of discussion basically is ammeter. So a galvanometer is a device which is used to detect current. Galvanometer is always connected in series. Why do we connect galvanometer in series? This is resistor. Let's suppose this is a bulb. Resistor, any resistor. Current, conventional current will flow from positive terminal and will pass through galvanometer. So if you want to detect current in a circuit, you have to connect galvanometer in series. What does it mean, series connection? The connection of different instruments in such a way side by side in such a way that there is only one path for the passage of current. If the current has only one path, then all the current will pass through galvanometer. Galvanometer will show minimum resistance. Resistance will be minimum. Minimum resistance means maximum current can pass through it. In order to detect current, it is compulsory that all the current must pass through this galvanometer. So galvanometer is connected in series. Any question? First thing is galvanometer is used to detect current. Device used to detect electric current. Excellent. Fine. Galvanometer is connected in series. What does series mean? Series means there should be one path for the passage of current. It is compulsory for the current to pass through galvanometer. Therefore, it is compulsory for galvanometer itself to have minimum opposition in the flow of current. Galvanometer must have minimum resistance, must have negligible resistance, must have negligible opposition in the path of current to flow for detecting the current. I think I have cleared the topic galvanometer. The screen will be more clear. Kids, please note, screen will be more clear if you place your mobile phone in portrait format or landscape format. So the screen will be more clear. Rotate your cell to full screen so that you may have a look on this slide clearly. Galvanometer can be converted into ammeter. By making some changes in galvanometer, we can convert it into ammeter. Now the question is, what is ammeter? I'm waiting for your answer. What is ammeter? Waiting for your answer. Ammeter. What is ammeter? Ammeter is basically a well-modified galvanometer. So why do we make some kind of modification in galvanometer to make it into ammeter, to convert it into ammeter? What is ammeter? Waiting for your response. What is ammeter? Waiting for your response. What is ammeter? Yes. An ammeter is an instrument which measures current flowing through the resistor. Galvanometer is used to detect current, while ammeter is used to measure current. Basically, it is a galvanometer, but we have made some kind of modification in galvanometer to convert it into ammeter. Ammeter can be connected in series, just like galvanometer. Have a look. Next question. How is an ammeter connected in a circuit? There are two types of combination of different resistors. One is series, line by line. Another is parallel, in which the current have multiple paths to flow. We have to measure current, so the whole current must pass through the ammeter. So ammeter must be connected in series, like this one. Conventional current will flow from positive terminal of the battery and will pass through the resistor, and the whole current will pass through ammeter. In this way, ammeter can measure the whole current flowing through the circuit. This is the connection of ammeter in a circuit that is series. In series combination of resistors, the current has only single path to flow. Okay, this is ammeter, this is cell. Is it clear? Have a look on the combination. How can we connect an ammeter in a circuit? This is a cell. Where is cell? Cell has two terminals. This is cell. Combination of cells is called battery. This is positive terminal of the cell. This is negative terminal of the cell. Ammeter has been connected in the series. Current have only one path to flow and the whole current will pass through ammeter. It is important to keep in mind the polarity of ammeter. Ammeter have two poles, one is positive, another is negative. The positive terminal of the battery must be connected with the positive terminal of the ammeter. It means the current should enter in the ammeter through its positive terminal and current should leave the ammeter through its negative terminal. While connecting ammeter or galvanometer in a circuit, it is important to keep in mind the polarity of ammeter. Ammeter have two terminals. One terminal is of red color. This red color terminal is positive. It must be connected with the positive terminal of the battery and current must pass through this positive terminal. Another terminal is of black color. This is negative terminal. Current should leave the ammeter through negative terminal of the battery. So this is the series connection of different resistors and the ammeter has been connected in series to measure the current. While connecting ammeter and galvanometer or voltmeter, it is important to consider the polarity of these instruments. The positive terminal of these instruments must be connected with the positive terminal of the battery and negative terminal must be connected with the negative terminal of the battery. Is it clear? So have a look on this figure. This is wrong connection of ammeter. Can you tell me what is wrong with this figure? Waiting for your response. Okay, students are saying that video is very bright. I am going to switch off the light so that it must be clear. Switch off the light, please. I hope now it is clear. Okay, have a look here. In this figure, ammeter has been connected in parallel. It is not connected in series. So this is wrong connection, because while measuring current, it is important that current must have only single path. Here the current has two paths, one from this side, another from this side. Ammeter in this case is unable to measure the whole current because some of the current is passing through this way. So ammeter must be connected in series. What is voltmeter? Take out your copies. You have to write it on your copy. What is voltmeter? The previous question, the first question was, what is galvanometer? Galvanometer is used to detect current. What is ammeter? Ammeter is used to measure current. What is voltmeter? A voltmeter is an instrument which is used to measure voltage or potential difference across 2 points in a circuit. Write it down. Hurry up. A voltmeter is an instrument which is used to measure potential difference. Is it clear to all of you? Write clear if you are clear with this definition so that I may proceed on. Waiting for your response. Write clear. Today we have discussed, very good, not fake is clear. Today we have discussed the definition of galvanometer, definition of ammeter, and definition of voltmeter. So the next question, voltmeter. Voltmeter, how is a voltmeter connected in a circuit? When we were discussing about ammeter, we explained that ammeter must be connected in series, but the voltmeter must be connected in parallel. What does parallel means? Parallel means the connection of different instruments in which current have more than one path. Okay, have a look. This is positive terminal of the battery. This is negative terminal of the battery. Conventional current will flow from positive terminal. Conventional current will flow from positive terminal and will pass through ammeter. Here ammeter has been connected in series. Ammeter will be able to measure the current. Then the current will pass here. Now at this point, the current will have two alternate paths. One current may go from this side, another the current may opt this direction. So we have to increase the resistance of voltmeter so that minimum current should pass through it. The resistance of ammeter is kept smaller. Please note this point. Is it clear? Okay. The current may have two paths here. One path is this one, and another path will be this one. In this path, the current will flow through the resistor. So in this path, the current will flow through the voltmeter. We are not interested in the passage of current through voltmeter. So we have to stop the current through voltmeter by increasing its internal resistance. We have to increase internal resistance of the voltmeter so that minimum current should pass through it. The voltmeter has been connected with the parallel. Parallel means इसी तरह the current is passing through this path and through this path, through this path. Through this path, the minimum current will flow through the voltmeter. And the voltmeter will be able to measure potential difference between these 2 points. So, voltmeter is used to measure potential difference between 2 points, and voltmeter is connected in parallel, and the internal resistance of voltmeter is kept very high to avoid the passage of current through it. Its resistance is kept high to compel the current to flow through this path rather than this path. Then the current will flow through this path and will move towards, charges will move towards negative terminal of the battery. So this is a comprehensive figure that is indicating that is indicating the connection of ammeter and voltmeter in a circuit. Ammeter has been connected in series and voltmeter has been connected in parallel. This is series combination in which there is only one path for the current to flow. This is parallel combination in which current may have more than one path to flow. We have discussed series and parallel combination. We have discussed about the internal resistance of ammeter and voltmeter. The internal resistance of ammeter is kept very low so that the maximum current may flow through it, and the internal resistance of voltmeter is kept very high so that minimum current should flow through it and the maximum current should flow through this path, and this has been connected in parallel just to measure potential difference between these 2 points. Voltmeter is a device which is used to measure potential difference across our resistors at point A and at point B. So have a look here. In this specific circuit, this is positive terminal of the battery, this is negative terminal of the battery. This is very important circuit. So the current will flow from this path, positive terminal of the battery, and will go through voltmeter. Have a look. Here in this circuit, no resistor is present. We are just going to measure potential difference across 2 terminals of the battery. We have connected voltmeter. It is important to keep in mind the polarity of voltmeter. Positive terminal must be connected with the positive terminal of the battery, and negative terminal must be connected with the negative terminal of the battery. In our previous figure, voltmeter was connected parallel to resistor, and voltmeter was measuring potential difference between 2 points A and B. But here in this figure, voltmeter is measuring the potential difference between 2 terminals of the battery. The potential difference between 2 terminals of the battery is usually expressed as EMF. EMF stands for electromotive force. Electromotive force is basically potential difference between 2 terminals of the battery. So if you want to measure EMF, you have to connect voltmeter directly with the 2 terminals of the battery. Internal resistance of voltmeter is very high, therefore negligible current will flow through it. If you want to measure potential difference between 2 points, then the voltmeter is connected in parallel. But if you want to measure potential difference between positive and negative terminal of the battery, you have to connect voltmeter directly. In this way, you can measure voltage of the battery. So that is named as EMF, electromotive force. We will discuss it in detail in next lecture. Note it. If you rotate your mobile phone to full screen, then it will be more clear. Please draw the circuit. Here is a voltmeter which is being used to measure electromotive force of the battery, which is used to measure the potential difference between 2 terminals of the battery. Hurry up, note it. Okay, well students, today we have discussed the connection of ammeter and voltmeter. Have a look on this figure. Voltmeter has been connected directly with the battery and negligible current. Why negligible current? Because internal resistance of voltmeter is kept very high to avoid the passage of current. So the negligible amount of current will pass through it. Have a look here. I have explained it earlier. Okay. This is from your textbook. Very important point. I am going to read it so that you may get full clarity. An ideal voltmeter must have a resistance very much larger. Why? To avoid drawing a large current from the circuit. While an ideal ammeter must have very low resistance so that the whole current may pass through the ammeter. So keep in mind the resistances of ammeter and voltmeter. This is a question from your P4. This is question from P4. We must be able to read ammeter and voltmeter. This is a question from P4 in which you have been asked to give the reading of this device. First of all, in order to write the reading of a device, three things are very important. The one thing is you must be able to predict the name of the instrument, name of the device. So tell me the name of this device. Waiting. Tell me name of this device. Waiting for your response. Tell me name of this device. Is this galvanometer? No. Is this voltmeter? Tell me, waiting for your response. Is this ammeter? Yes, this is ammeter. How? Because the quantity which is being measured by this instrument, by this device, has been given unit of milliampere. Ampere is the unit of current. Ampere is the unit of current. So this is a device which is measuring electric current. So what is the quantity of electric current? One thing. If you have been asked a question regarding taking the reading from instrument, 3 points are important. Number one, you must be able to name the instrument. So this is an ammeter, it is clear. We can name the device, we can name the instrument by having a look on the units that are being measured by this instrument. As this instrument is measuring milliampere, it means ampere is the unit of current. This instrument is measuring current, so it must be ammeter. This was the number 1 point. Number 2 point. Have a look on the calibration. Have a look on the scale. And you have to find that for which value the 1 division stands for. Just look between 2 and 4. This is 2. This is 2.2. Let's see. This is 2.4. No, this is 2.6. This is not so like this one. We have to predict the value. 2, 2.5, 3, 3.5, 4. Yes, I have got the idea. just by looking the number of divisions between two calibrated points. This is 2, this is 2.5, this is 3, this is 3.5, this is 4, this is 4.5, this is 5, this is 5.5, here is 6. So we have predicted the idea of calibration. So each division is showing 0.5. Here is 10. This is 10.5. This is 11. This is 11.5. So the needle is at 11.5. This was the second point. First, this is a question from P4. There are a number of questions in P4 regarding taking the readings, because this is a practical work. So, while taking the reading, you must be able to predict the name of the instrument. Number 2, you must have idea regarding the calibration. Here is 11.5. So the third important point is you must write the unit. If you are not going to write the unit, you will not be awarded with any mark. So the reading is 11.5 milliampere. Is it clear? Have a look. 11.5 milliampere. Got it. So let's move to the next figure. Now it will be your exam. It will be your test and you will have to solve it. Have a look on this figure and answer my different questions. My first question is, which instrument has been shown on this slide? Tell me the name of instrument, please. Tell me the name of instrument. Which instrument is here on the slide? This is voltmeter, because the quantity measured here on this scale is voltmeter. It's volt, millivolt. So this is the voltmeter. First point is clear. The name of the instrument is voltmeter, and it will measure potential difference, or it will measure voltage, or it will measure EMF of the battery. Because voltmeter can be used to measure potential difference, that is called voltage, or voltage of the battery direct, that is called EMF. Voltmeter. What is the reading? We have to, first of all, we have to perceive the idea of calibration. This is 2, this is 2.5, this is 3, this is 3.5, this is 4. 4.5, 5, 5.5, 6, 6.5, 7. So while taking a reading from analog voltmeter, this is an analog voltmeter in which there is a needle. While taking the reading, precautions are very important. Your eye must be at 9 angle to the position of this needle. If your eye is not straight on this position, the reading may be doubtful, and that error in the reading is called parallax error. Avoid parallax error. We have to avoid parallax error. What is parallax error? Parallax error is the doubt or error in the reading because of wrong position of eye. So here in this case, the reading is 7 milliampere. It is important to write the unit as well, milliampere, because in calibration the unit was mentioned. So next question again has been taken from your past papers, P4 2009, October, November. This is a question from P4. So, this is a voltmeter, this is ammeter. We have to write down the readings. Can you have a look and can predict the readings? You have to solve the question P4, 2009, October, November. So the readings are 1.4 volt here and 78 milliampere here. P4 2009. This is P4 2016, October, November. Record the readings. Current. Here the current will be measured through ammeter. Have a look on the values. This is 1, this is 0, here is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9 and 1. Here the reading will be 1, 1.1 and 1.2. The reading is 1.2 and here the reading is 8.6. Again, the question is from 2017, P4, October, November. State the reading V on the voltmeter. Here, waiting for your response. Tell me the reading of this voltmeter. Tell me the reading of this voltmeter. Waiting for your response. I'm also observing your attendance. Waiting for your response, for your answer. What is the reading on voltmeter here in this case? The reading on the voltmeter is 2.8. How? Here is 1, 1.2, 1.4, 1.6, 1.8 and 2. Each small division is showing 0.2 volt. So 2.4, 2.6, 2.8, 2.2, 2.4, 2.6, 2.8. So the value is 2.8 volt. So in this case, in this way, different questions can be asked in your paper P4 and P2 regarding taking the readings. Have a look here and you will have to tell me the reading. Hasnan was saying that the reading is 2.9. Hasnan, the reading is 2.8, not 9, because the each small division was indicating 0.2. Here the reading on this scale, if it is not clear, you must go to P4 2018, October, November. You will find this figure and you can practice there. So the answers has been given 1.2 and 1.65 ampere. 1.2 how? Look here. This is 1. This is 1.5. No. How? This is 1. 1.5 is here. 1, 1.1, 1.2, 1.3, 1.4, 1.5. So in this way we can perceive, we can predict the calibration. After predicting the correct sequence and correct order of calibration, we can answer these questions. Again, this is question from 2014, May, June. The question is, state the quantity measured with voltmeter. We can measure EMF with the voltmeter. We can measure potential difference with the voltmeter. We can measure voltage with the voltmeter. And what is the value here? 3, 3.2, 3.4, 3.6, 3.8 and 10. This is 3.6. We can measure EMF, potential difference and voltage with the help of voltmeter, and the answer is 3.6 volt. Well students, today we discussed about ammeter and voltmeter. We will carry on in the next lecture. Thank you very much.